Okay, so this is our project kickoff. I'm gonna first go through the project prompt, and then I'm gonna talk through these guidelines. Now, keep in mind that right on the tails of this project is your capstone project, where you do have 4 weeks for. So any of these guidelines, again, depending on what you decide for your capstone, these guidelines will apply to your capstone project as well. So this this guideline doc is already linked to your homeroom. It's probably going to be something that you refer back to. But anyways, this is our last project before your own solo capstone project. Again, I do want to make it as seamless and easy as possible. So I'll talk through some ways that you can make this project easier for yourself. And because there are 4 quite different projects, I'm going to go one by one. The only one, because I don't think anyone is doing this, I'm going to skip over recommendation systems for today. For recommendation systems, I'll talk a little bit more about that during the capstone time, because I don't think anyone in this class is working on it. If anyone is working on recommendation systems, ping me in the chat or something so I can talk about it. But as far as I'm aware, no one is working on that. Okay, so to start, let's go problem by problem. I'm going to start with time series modeling first. I know quite a few of you are considering doing time series for your capstone as well, so I think this will be useful information too. Now, for this phase 4 project, the provided data set for time series is actually very interesting and not traditionally how time series is done. This project basically gives you zip code data, monthly zip code prices, monthly median average zip code prices for a bunch of zip codes. I think they have about 200 different zip codes. And the idea here is figure out a way to efficiently do time series modeling to then make suggestions for what are the top 5 zip codes to invest in. So that is what the provided question is. Now, because this project is structured in a way that you are running a bunch of time series models on a bunch of different zip codes, it's actually not very similar to how you would typically do analysis. Typical time series analysis is you just have one time series and you're trying to do predictions on that. So with that, and this is also monthly data, you can totally do this with about 200 zip codes. I'm also fine if you cut down the zip codes to a more manageable number. Maybe you want to like narrow it down per region or per, I don't know, per zip codes that you're familiar with. I don't know. So feel free to cut down the scope of this project. I'm more than happy if y'all do that. Or if you want to do something a little bit more along the traditional route, feel free to look up your own time series data. Just anything that has its data in chronological time steps, just send it over to me so that I can just take a quick look before I approve it. But most things will be fine. You can totally replicate this project with things like stock data, other housing data, anything time series really. So yeah, with this project, actually I'll talk through the details later. All right, so I'm going to skip over recommendation systems for now, but for those of you who are just curious, or perhaps after you graduate, you want to take on these projects, this recommendation system project is basically the movie lens data set, which is, I think, the one that I went over during our, did we go? I don't remember. I think it's the one that I talked about at our study group, but basically it is building a movie recommendation system using surprises SPD. Cool. So this one, quite a few people are working on as well. Image classification with deep learning. The provided data set is on pneumonia x-rays. So for pneumonia x-rays, it's a bunch of like chest x-rays. Some of them have pneumonia, some of them don't. I forget if there's a third class, but basically classification problem. Now with image data, EDA is actually not doable the same way that we would with other data. So in a little bit, I'll talk through ways that you can do visualizations for this project. But yeah, that is the data set, and very similar to the code I was showing you yesterday, you'll just be implementing neural networks, either a regular dense neural network or convolutional neural networks. And then finally, we have NLP project. The provided data set is Twitter data from South by Southwest, I think back in 2012, so it's a little bit outdated. I'm going to show you all later a library that you can use if you want to quickly get different data for your NLP project through Twitter. So I'll show you all that in a little bit. But this the only difference between this and our last project is just the data type. The process of this project should actually be very, very similar to our classification project, because this is also a classification problem. I believe this one is on sentiment. So basically a bunch of tweets about South by Southwest. You're just trying to predict whether it's positive, negative, or neutral. Feel free to drop the neutral class. I think even here it says, yeah, you can start by limiting your analysis to positive and negative tweets only, allowing you to build a binary classifier instead of positive, negative, and then neutral, because neutral is always the one that's a little hard to predict because it is in between the two. So yeah, again, for any of these projects, if you want to source your own data, just let me know. All right. Any questions before I start getting into the details of like my expectations for these projects? I'll also start talking about collaboration and ways to go about that for this project. Okay. So with guidelines, let's skip over this one, but if you do plan on doing a recommendation engine for your capstone project, the same guidelines will follow. Okay, so for time series, the business case for this time series project, the one that's provided, because you're trying to predict and forecast and also select the zip codes, naturally your business case will be around capitalizing on your predictions, whether that means looking for market opportunities or looking for just the ones with the most projected growth. That's up to you to define. In terms of EDA, it's really going to differ on what you decide to do with this data set. Because you have data on about 200 different zip codes, there are a lot of different ways you can think of EDA. So for example, think about how you can make your EDA a little bit more efficient. Maybe you want to group your different zip codes together. Yeah, because you don't want to do an EDA for every single zip code. That's going to be just a lot. So again, the standard EDA for time series, check for stationarity, seasonality, ACF, PACF. And also after you're done with your modeling, maybe you want to include exogenous data. This is optional, completely optional for this project. Now, one of my tips for this kind of EDA, you can actually cluster your time series data. If you want to take your 200 zip codes and maybe cluster them into perhaps 3 or 4 groups of zip codes, and then either narrowing it down to 1 or using an aggregation of each group of zip codes, you can do that as well. So maybe based on your clustering, it's not going to be as neat as this, but maybe based on your clustering, you find a set of zip codes that the price has decreased over time, a set of zip codes that the price increases over time, and a set that's like fairly stable. You can form your analysis around that. You can be pretty flexible with this. As long as you're doing some sort of time series forecasting and predictions, I'm okay. Questions on this time series project? Cool. So with the modeling, think about how you're going to do your train test split. As I mentioned, was it 2 weeks ago now when we were talking about time series? The train test split is not as straightforward as just a random shuffle. Really take into account where you're doing your train test split. I'll tell you, for that provided data set, if you do an 80-20 split, even chronological, it happens to be right around the financial crisis. So if you were to choose the standard train test split, it's actually not going to be, you're not going to get good predictions just because of exactly where the split takes place. It's a completely different trend before and after the split. So do take note of that. For your baseline model, you can pick one of the simpler time series models. You can also just pick the average price. That is a valid baseline model as well. And then you also, in terms of iterative modeling process, you do want to start with your traditional time series models, especially if you're working on this data set or something financial. It is always important to show that you know how to use these linear traditional models. So definitely start with the ARIMA-like models. And then you can possibly, or probably you'll end up doing auto ARIMA to pick the best parameters for you. Again, I've linked the walkthrough of auto ARIMA there. Cool. And in terms of your business recommendations, if you're choosing this data set, it's obviously what zip codes you want to invest in, but it is also important to address the caveats. There are a lot of limitations to using time series models, especially the linear traditional ones. So do think a little bit more critically about, okay, how sure am I about these predictions, and what are the caveats that you would tell maybe someone that you're trying to advise with these time series models? Cool. All right. Anything before I move on to talking about NLP project? Okay, so for NLP, I do want you, whoever is doing the NLP project, to stick to classification for now. But with the data set, I'm again later in a little bit, I'm going to show you all a library that allows you to grab different Twitter data if you decide to use different data. But again, the same concepts, classification concepts hold from the last project to this project. So think of your business case. What are you using this NLP for? What's the final product? For the provided data set, it's sentiment analysis on tweets at South by Southwest. I think that year, like the iPad had just come out. I think it's iPad and also like Google Circles, if anyone remembers that. So there are a lot of tweets surrounding those things, and maybe you can frame it something around like market analysis, because that I think is the event where those things were unveiled for the first time. I forget. But yeah, in terms of EDA, make sure it's comparative to aid in your modeling. Word clouds, again, for the presentation. So, but I still want to see some quantitative equivalents. So bar graphs of your word counts. Maybe you want to normalize it. Maybe you want to do it a little bit more comparative between your classes. Very, very similar to the EDA that you all did last project. And you all did a really good job with that EDA as well. So I'm not too worried about that. If you want to level up, you could try clustering your data or doing some LDA for topic modeling. If you remember, topic modeling was the thing I talked about at the end of last week, that it actually shows you what were the main things that were being talked about. That's actually a very, very strong EDA tool. Just give you an overall broad sense of what the tweets overall are talking about. So the approach to this project is slightly different in terms of, because you have different NLP pre-processing techniques as well as different models, you can kind of pick and choose. And maybe for those of you who are working in groups, you can prioritize different things and maybe divide and conquer in a way that allows you to do a more broad analysis. So first of all, there are different kinds of pre-processing techniques, right? We talked about, even just within the bag of words methods, there's two, right? There's count vectorizer, there's TF-IDF. You can maybe spend your time working through some functions to make this process a little easier to work with. But yeah, you can perhaps try different processing techniques, count vectorizing, TF-IDF, perhaps word embeddings and feature selection for each of these. Again, word embeddings is completely optional for this project to see how it affects the performance of your models. If you're taking more of a pre-processing approach, I would say, because you want to do more of an apples to apples comparison, make sure that you are comparing the different pre-processing techniques using the same models for the apples to apples comparison. I personally like to try definitely tree models so that you can get your feature importances. But again, as I talked about when we talked about the models before, naive Bayes is usually the one that performs best on text data. If not, if you know what kind of pre-processing you want to do, you can pretty much do a straight up modeling approach that was very, very similar to the last project. So maybe you pre-process your data at the start, feed it through that function that you created last time. It should work the same. So you can do that as well. I would say, because, especially for the groups of like 2 or 3, or the group of 2 or the group of 3, maybe each of you pick like a pre-processing technique and try your modeling and compare your results there. That's actually a really easy to like divide and conquer approach to this project. Finally, post-modeling EDA for this project is going to be especially important, especially if you're doing some of the bag of words methods. Doing a comparative analysis, comparative feature analysis on words is going to be a lot, because prior to this, when we were dealing with our numerical classification data, we did not have as many columns. So we weren't, so we could look at the per class distribution of a specific feature. Now, it's very hard to do this with NLP because every unique word becomes a feature. So therefore, for whatever ends up being significant variables for classification, look up that specific word, do that comparative bar graph, same as we did for our last classification project. In terms of recommendations, it's very important to draw recommendations from your models. I did talk about this with a lot of you at our project reviews for the last project. So things like, what words led to classifying your sentiment as positive or negative? Maybe it's not as obvious. Maybe it's not like the words like good or bad. Perhaps every time iPad was used, tended to be more positive, and every time like Google Circles was used, it tended to be more negative. So if you think about that, again, connected to your business case, but if you're taking this data set, how can Apple or Google adapt with this model to better serve their customers? Just as an example. With this project, I am going to be a little bit more nitpicky on the business case, especially because going into the capstone, it's a unique project. Your capstone is going to be a unique project, and you want to set up a very strong business case just to show people that you're able to make these business recommendations out of your data science project. Cool. Now, to talk about getting data, I will tell you now that I broke my environment a couple weeks ago, so this currently doesn't work on my computer. I'm going to push this notebook up after I figure out what's going on and making sure that it's just my computer and you all should be okay with this. There is a library called Twint, and what it is used for, it's an open source library, and basically it speed scrapes Twitter for you. So right now this won't run properly, and I also did this like at the start of the year when COVID was more prevalent, I guess. So what this does is allows you to do a quick search on Twitter. So in case you don't want to use South by Southwest tweets from 2012, you can just come up with your own search terms to create your classes for you. So when I last was working through this notebook, it was when height of the pandemic. So with this, you just have to set up your Twint, which is basically your Twitter scraper, and set up this kind of code. I've also linked to other attributes that you can use to narrow down your search. In this case, I'm basically looking up any tweet that has the word COVID in it, with a minimum number of likes being 100, because I don't want to get all those noisy tweets by like random people. Saving the count, and also 100 tweets. This is me getting 100 tweets, and I can store this data straight as a CSV, which is really neat. If I run this, it actually does, it should create a CSV automatically. I am going to debug this a little bit later, and I'll push up a version onto our study repo. But this is a really, really quick way. It should take you no more than, well, depending on the number of tweets, and again, 1,000 per class on average. Yeah, it should not take you very long. I'm just going to figure out exactly what's going on my computer, because this will not run. But yeah, you can do different things like look up. Oh, yeah.
If you run it multiple times, are you going to get the same tweets, or will you get new ones?
So this actually scrapes the tweets in chronological order, because I believe that's by default how Twitter search works, I think. So it is in chronological order. If your search parameters are very strict, you probably will get the same tweets, because not many, I will assume that not many new tweets with those strict parameters will come through, but it will scrape it in chronological order. There are also parameters that you can set to get within some sort of date range. You can control for that as well. And that's all in here. Yeah, you're welcome. So yeah, this is a really neat library. I do want to get more into this when we start recapping APIs and web scraping. Actually, that's what this notebook is for, actually. So I'll show you all this notebook again, probably the first week of capstones. Yeah, the first week of capstone, we're definitely going to see this again. But yeah, you can see that there are a bunch of other things that you can search for, things like a specific user. If there's a location, you can actually look for that. If you want things with mentions, photos, so on and so forth, a lot of different things. Like you can see, where's the date? Well, there's a date somewhere. I think created at is the date parameter. But yeah, there's a bunch of things here. If you actually look this up on Medium, there are a lot of walkthrough articles that basically give you the code to get tweets really, really quickly. But cool. I just wanted to share that this is a pretty useful library. Most people who do NLP, it's the easiest to get data out of Twitter. So yeah, this is a very commonly used library. And Twitter API is difficult to get authentication for. So yeah, questions about the NLP project? All right, in terms of collaboration, because I know most of you all are working on either NLP or the image classification project, which I'm going to talk about next. In terms of collaboration, I do think the easiest way, now that we are aware of Google Colab, which is what I was using to run the neural networks, this past week, definitely, if you want to just, work within one notebook, you can definitely just work off of Google Colab. Now, actually, I forgot to pull this up earlier. If you want to use Google Colab and have your data file, make sure that each person has a copy of the data file, and you do need to have a Google account to use this properly, because what you want to do is you want to actually have your data file in your Google Drive. So what you do here, and let me see if this will show a bit of example. At the very start, to get it to read your data from your Google Drive, you just have to paste this at the top of your notebook, and it'll actually prompt you to sign into your Google account. So sign into your Google account. It will give you this code where you just copy and paste this code, enter it here, press enter, and it'll tell you that it will be mounted. You give it a little bit of time there, and you see how it's mounted at Content Drive. What I meant to do was create a new cell, but the shortcuts are not the same. If you do ls, you can see that this is my Google Drive. So if I actually do cd drive and shift enter, this is the content in my drive, and this, at this moment, I'm already in my drive. And if I ls, this is all the stuff that's in my drive. Let me cd into my drive real quick. This is my drive, new code cell. And you can see that these are all of these are all the files I have in my Google Drive. So this is how you can read in your CSV if it's in your Google Drive. It might be a little bit different depending on how you all organize your Google Drives, but you should each be able to independently work off the same data file. Also, if multiple people are working off the same notebook at the same time, your kernel is not shared. So you can each run different parts of the code independently, basically. But of course, if someone makes changes in a cell, it is not as fast as Google Docs. I think there's about like a 20-second delay when code is being updated, but it's still a lot better than how Jupyter Notebook's not merging properly. So you can definitely do this. Of course, this means that it doesn't always connect to GitHub. However, you can export this as where's the export? You can download this as an IPYNB file. It can also automatically save to GitHub. So in setting up your repo for this one, several ways you can do it. You don't have to worry about the branching as much because you're all working on the same document. This also auto saves, and you can also go back and look at prior versions. I think if you go look at, let's see, where is that? I forget where it is, but there's somewhere where you can see, revision history. So you can see all the different versions just within here. So it actually does your Git version control for you. So if you accidentally delete something, you can look for it. Cool. Questions about Google Colab? For any of you who are collaborating, or actually even if you want to, for your capstones, or even if you're not collaborating, you can totally use this as well. For this, you can basically work off of any machine. The only downside is you might have to keep pip installing the necessary libraries, because I think by default, it doesn't have all the libraries. You might have to just pip install each one.
I have a question. How does the GPU thing work with Keras? Does that use your GPU then to process it? Because I might have a GPU that could do that.
Okay, yeah. Actually for Google Colab, I know that you can use their GPUs. I honestly am not sure how you can connect Google Colab to your own GPUs. I know that people have been able to do that successfully if they're doing it within Jupyter Notebook, but I have a Mac, so I don't know how to do that. But from here, I know that didn't answer your question, Justin, but from here, for those of you who want faster processing, perhaps you just go into runtime, take a look at change runtime type, and you can switch the processor that you're using. But actually, yeah, I'm not too sure about using your own GPU with Google Colab. That I'm not too sure. Yeah, I know I didn't answer your question, but I don't know the answer either.
Yeah, because I know certain GPUs can help processing speed. I can't remember if mine actually can on my PC or not.
Yeah.
At this point, I'm wishing I would have upgraded to the 5900 instead of the 50 CPU to get the extra 16 threads instead of 8. to get 16 cores instead of 8. But yeah, okay, I was just wondering how that worked, if you knew.
All good, all good. I know that I would say for this project, even if you're doing the image processing project on your local machine, it should be able to run without breaking your computer. It just depends on how fast it is. So I've seen that project been done. I've seen this image processing project be done on local machines. There's no issue. But yeah, there are different things that you can play around with, which I'll talk about at perhaps some office hours. Cool. What was the last thing I was talking about? Any other questions on Google Colab? Right. In terms of like configuring GPUs, since we were kind of talking about that, I know that's something that you can configure actually with TensorFlow, which is what Keras is built on top of. So you can definitely configure that with TensorFlow. I don't know how to do that because I've never done it myself, but it seems like there are a bunch of resources because students have been able to do it on their own. Cool. All right. So last but not least, to talk about the image classification project. So for this classification project, the task the business case lies in the task itself. You want to basically be able to detect abnormalities in the chest X-rays, and specifically looking out for pneumonia in this provided data set. So EDA is much harder for images because your one data point is represented by an image, and those pixels don't really give you much information if you do it like a feature by feature EDA. So for this project, the EDA is going to be very, very light. So do as much of a summary as possible in this section. Literally, like you can output a couple images just so, you know, in your notebook, you can see that in your flow. Also the class balance. What's the class balance of this data set? Is there, you can also, by the way, smote image data, but yeah, very simply an overview of this data set. This modeling process, I think most of this project will be spent on setting up the models. So as with the last project, you should start with a baseline model, up to you to decide what that will be. It can be a single layer network, like a single like dense layer, as we mentioned yesterday. One for dense, for regular dense networks, images probably won't be classified very well. You can even use a scikit model if you want to use like the dummy classifier, or even like flatten out your image data and run it through like a, I don't know, like a random forest or naive Bayes. You can actually totally do that as well. But yeah, for this project, the experimentation here is really an experimentation because of the complexity and uninterpretability of neural networks. Is just experimenting with a bunch of different kinds of models. So you can experiment with different structures. I recommend including convolutional layers, though it's technically not required. It's really just a matter of adding in those different layers. So I do highly, highly recommend that you do add convolutional and pooling layers, which is what I talked about yesterday. So to level up, I'm going to talk about a couple of these tomorrow. So pre-trained networks, that's something I'm going to talk about tomorrow, is basically you can use models that have already been built to as layers in your neural network. I'll talk about that tomorrow. Visualizing intermediate layers. So you can actually get visualizations of where is this network looking at a particular point of time. That is actually in one of your appendix. I think it's in the appendix labs. It is definitely a lab somewhere in your Canvas curriculum. And also you can deal with class imbalances with data augmentation. This is really interesting. Data augmentation basically means that, okay, let's say I have all of these chest X-rays, and chest X-rays is not a common use. Well, doing data augmentation is not a common use case for chest X-rays, but the idea of data augmentation, and there's actually a built-in library for that within Keras, to have it recognize abnormalities or things about each class more, it actually creates copies of your image, but just slightly different. So they'll actually do things like, you know, do a 180-degree flip of your image or rotate the image a little bit. You can imagine if you're trying to do a classification like cats versus dogs, you want it to recognize not like specifically a dog standing straight, but you want to maybe see like, okay, if I don't know, dogs like rolling over or something, you want it to recognize that as well. So that's data augmentation. I do think it is in one of your labs as well. So also, I do want to see at least one iteration of tuning being done. Tomorrow, this is what I'll be talking about as well. So I'm not going to talk through that now. So when you're making changes to your model, I know right now is going to be a lot of hypothesizing of being like, oh, perhaps adding a couple more layers will make this do better. It's important to document why you're deciding to try something out. If your reason is just to try it and your hypothesis is hopefully it'll improve, do mention that as well, because it's very, very important to keep track of what it is that you're doing. Yeah, and will the accuracy improve? Just keep track of all those metrics as well. So for recommendations for a neural network project, the recommendations can be a lot more qualitative or general, again, because it's very hard to get information out of your model. Perhaps through the visualization of your intermediate layers, you're realizing that the network is starting to focus on certain things. Potentially, you can also make recommendations on the model's architecture. If, let's say, you run out of time and you don't have time to like run a model for like 7-8 hours, you could say, okay, well, based on the progression of my iterations, I saw a great improvement when I added convolutional layers. So in your recommendations, you could say, you know, literally add more convolutional layers. So that is a valid recommendation for a neural network project too. There's also a library that I will hyperlink back here where, and this is I think it was newly updated. And there's a library that you can actually overlay a heat map to find out most important pixels per image. So let's say if you have a chest x-ray that looks normal and you have a chest x-ray that has pneumonia, it'll focus on like the pneumonia clouds and it'll show you like a heat map, and it says that it'll basically, you can infer from that that the network is realizing that these like clouds or splotches are a sign of pneumonia. So that's super interesting. Cool. So that was like a very brief overview on each project. Based on the questions that I'm going to get over the rest of the week, early next week, that will guide our office hours as well. I am still thinking whether we'll do more deep dives into specific topics, because we will be doing that during the capstone as well, or doing more project specific Q&A. So we'll see based on the questions that I get from you all. But also there is a bunch of Q&A. This has been collected over a bunch of cohorts in the past. So if you have questions, or if you're just curious as to like what people were working on, feel free to look here as well. So yeah, there's a good number of questions for each project topic. But yeah, at this point, does anyone have any questions? Okay, again, if any of your project partners are ghosting you, please let me know, sooner the better. And then, yeah, if there are no further questions, going once, going twice. Cool. Tomorrow, we're going to continue with our neural networks. We're going to talk through some of the tuning things, like doing a grid search for a neural network. Also doing more of the time series applications of neural networks. So we'll talk about that. But yeah, cool. If there's nothing else, I will see you all tomorrow, same time. That'll be our last like official phase study group, which is, again, like so crazy that time has flown so fast. But I mean, yeah, we have 4 more weeks of capstone anyways. Cool. Feel free to send over your questions if you all have any, but if there's nothing else, I will see you all back here tomorrow. Cool. Bye, everybody.